Hi, I have a 5-ton AC unit cooling just shy of 2,000 square feet. My air return is built into a sealed box positioned between two walls at the bottom of the second floor. The box pulls air from downstairs through a 12 by 24 filter and upstairs through two separate 16 by 25 filters. The return duct running from the box to the air handler is 18 inches diameter or 4 flex duct. To make the duct fit, it, and the start collar, was compressed into an oval. Over time, the flex duct has collapsed a bit, which is choking down my airflow. I'd like to replace the flex with rigid duct. Is 18 inches sufficient, or would I be better off upsizing a bit? Would a single rectangular duct be best, probably a bit more expensive to have fabbed, or could I use two round ducts side by side going into my attic and combine them with a pants Y? From there, it's a straight and easy shot to my unit. What method and size combination would be best?
Welcome to Just Answer. We can start from the basics, and that will help get us on the same page about what the options are and why. The shorter the return air duct, the smaller it can be. 18 inches round, however, is way too small for virtually all 5-ton systems. There are several tests we will do later to see how it is performing with the small returns. 700 feet per minute is maximum velocity in the return ducts. Minimum airflow is generally 400 cfm per ton, or 2000 cfm for your 5-ton unit. In a dry climate such as Arizona, 500 cfm per ton is most efficient. In a damp climate such as Florida, 350 cfm per ton is good. The lower the air volume, the more a system dehumidifies. Let me know where you are in the world. Nearest city will work. Sizing example. Using 400 cfm per ton, that's 2000 cfm. 4 square feet of return duct will result in a velocity of 500 feet per minute. If the return duct is over 30 feet long and has a few elbows in it, then a return duct 24 inches by 24 inches would be way more than ample. 20 x 20 inches, 400 square inches, would result in airflow about 700 fpm. Many contractors size for 700 fpm return ducts. That works in most cases. As you go below 400 square inches in the return duct cross-section, the airflow is restricted, and operating costs begin to climb. If you get below 300 square inches, there can be coil icing problems. If you get below 200 square inches, icing the coil is almost a certainty, unless the return duct is under 5 feet long, approx. The area of an 18-inch return duct formula is A equals the radius squared x 3.14, so that A equals 81 by 3.14 or 254 square inches. Look all that over, tell me where you are in the world, tell me how long the return duct is and about any elbows in it. We can go from there. Phil.
Hi Phil, I live just outside Houston, Texas, the land of heat and humidity. The return duct is fairly short. It's about 6 feet from the top of the chamber between the walls to my AC. From there, I would need a 90-degree elbow, 2 to 3 feet of horizontal duct, and another 90-degree elbow to connect the duct to the unit. Thanks for your help.
Hello again. Your 18-inch duct borderline too small, but given the lower airflow per ton required in Houston, it may very well be workable. To check that, we need to use one single thermometer to check the temperature at the cold air duct closest to the air handler. Over a few days' time and in various conditions, especially as it begins to drop below 75 F outside and the inside of the house is still warm. We not want that air temperature to drop much below 50 F. At 45 F, the ducts will sweat, and moisture from that can cause mold and dry rot in structure. If you see signs of rust or corrosion around the cold air vents, that's an indicator of such problems. We are looking for the cold air supply temperature to be between 18 and 22 degrees Fahrenheit cooler than the return duct temperature, and no colder than 47 F worst case. Auto supplies have a good thermometer for that check. Buy one that reads from 0 to 100 F ideally. $8 or so. Let me know what you can find, we can go from there. I spent some time consulting for oil companies there in the 90s. Humid is not the word for it, more like a steam bath. If you wish to rate my assistance so far positively, I will hold the question open for any needed follow-up. Thanks. Phil.
What type of consulting did you do? I've been in the industry for close to 30 years now. Assuming I bump the duct to 20 inches, do you see a difference between one rectangular duct versus two round ducts as long as the cross sections are near each other? I'm guessing that my current duct restriction is increasing the air velocity a bit. I've noticed that my house is a bit dustier lately. I'm wondering if velocity could be a contributing factor. Thanks.
Hello again, I retired 2 years ago. I do mostly specialty air conditioning and refrigeration for semiconductor manufacturing, food processing and petrochemical plants. And a few years working for our nuclear weapons folks, mostly on cleanup projects. I am a mechanical engineer, but do most of my own control systems. As long as you have the suitable inch-2 cross section, it does not matter if the duct is round or square. Corrugated flex duct, however, is about 15% more restrictive than rectangular duct with its smoother surface. Leaking return ducts will suck dirt into the system, along with running your operating costs up dramatically. The higher the velocity in the return ducts, the worse both of these issues becomes. Phil.
If you have a home improvement or appliance question and want to chat with an expert now, visit JustAnswer.com/YTHI.